Hi, welcome to this lesson on calculus, finding tangents to functions. Let's have a look at question 2 for this equation. Alright, so find the equation of the tangent line to the function f of x equals 4 over x minus 1 at x equals negative 1. So again, let's recall the equation of a tangent line is given by the straight line form, y equals mx plus c, where your gradient m is evaluated as the first derivative at that point of contact, which in this case is x equals negative 1. Okay, first of all, we don't have the point of contact. We're only given the x-coordinate. So let's find the y value. So f evaluated at negative 1 is 4 divided by negative 1 minus 1. 4 divided by negative 1 is negative 4 minus 1, so I get negative 5 as my y value. So the point of contact, let's call it p, is negative 1, negative 5 on this function. And this function is a rectangular hyperbola, right? This is a hyperbolic function because it's of the form k over x, or k over x minus p plus q, right? It's the general form of a hyperbolic function. So in this case here, what we have now is that the derivative, right? We need to apply the derivative of this function, but the x is in the denominator. So to make it in the numerator so I can use the power rule, I can bring it up and say this is 4 times x to the negative 1 minus 1. So now I can use the power rule here and the difference rule. So it's 4x to the negative 1, take that derivative, minus the derivative of 1. The derivative of a constant is just 0. And then here, if I use the power rule, I bring down the negative 1 and multiply it, and then subtract 1 from the exponents. So I get negative 4 times x to the negative 2. But I'm going to rewrite this as negative 4 over x squared using exponential laws, right? Because we don't like negative exponents. So that is the derivative function. So therefore, the gradient is going to be the derivative function evaluated at negative 1. It's going to be negative 4 divided by negative 1 squared. Negative 1 squared is positive 1. So negative 4 divided by 1 is negative 4. So you can see here that the gradient of the tangent line is negative 4. Notice the big difference that when you're applying f prime at negative 1, that is the gradient of the tangent line at that point. And when I applied f of negative 1, that gives me the coordinates, that point of contact between the graph, f, and the tangent line. Okay, so now what do we have? So let's write this out here. So far we have the tangent line is y equals negative 4x plus c. Now I substitute my points of contact, which is negative 1, negative 5. So I get negative 5 equals negative 4 times negative 1 plus c. So I get negative 5 equals 4 plus c, and then taking over the 4, I get c equals negative 9. So the equation of my tangent line is negative 4x minus 9. And again, let's see if we can get a rough idea of what this looks like, right? So this is a hyperbolic function. 4 over x would generally start out looking like something like this in the dashed lines. It's a hyperbola. But then we are shifting everything down by 1. Okay, so there's a new asymptote at y equals negative 1. Okay, this is from your functions knowledge now. So you can see how functions and calculus play hand in hand with algebra as well. So all the various branches of mathematics are coming together, a nice culmination. Okay, so if I do that, the graph roughly would look something like this. So let's try to get a rough sketch. So to approach the asymptotes like that. And the y-axis is still an asymptote here. And it would go something like this. So everything is just shifted down 1 unit. So that minus 1. That's from your function transformations. So where was the point we were looking at? Negative 1. Okay, so negative 1 is here. So at that point here, we had negative 1, negative 5. And we can see that makes sense on the graph. And when we draw a tangent line to that point, it's going to look something like that. Can you see at that point of contact, this gradient is definitely negative. It's sloping from left to right down. So negative 4x minus 9. And that y-intercept there is negative 9. Okay, so that is the equation of the tangent line for this hyperbolic function at the point x equals negative 1. It's a negative gradient. All right. Awesome. I'll see you in the next one.